8th grade math students, let's talk about this Unit 4 practice test, because you're going to have a Unit 4 test coming up soon, and we want to make sure we know how to do good on it. So this review video is going to be a way for you to make sure that you're ready for the actual Unit 4 test coming up soon. All right, in this review video, I'm going to give you an answer key that tells you all of the answers to this practice test. Once you see all of those answers, you can see how you did. But in this video, if you need help with any problems, feel free to fast forward to the problems you need help with. You can rewind, skip around. You do not have to watch this entire video start to finish. Just watch the parts that you need help on once you've seen what all the answers are. Okay, so here we go. Let's jump in. I'm just going to throw the answer key right up here onto the screen for you. Here we go. All right, so number 1 is worth 2 points. Number 2 is worth 2 points. Feel free to pause the video for a second and take a look at that. Number 3 is also worth 2 points. Feel free to pause the video again. 1 point for the graph being right, 1 point for the solution being right. Then number 4 and 5 are word problems. All right, so number 4 is just worth 1 point, number 5 is just worth 1 point. And on number 5, you could have it in the other order. If you wanted to, you could have 40 and 51. But on this one, could you have it in the other order? No. Yancey's 2 and Xavier is 1, not the other way around on that one. Okay, that's important. That's important. All right, the back side of your practice test should look like this. Again, feel free to pause the video. Let's see if I can fit all of the answers right here on the screen. Feel free to pause the video, take a look at those solutions, check them. We'll come back and explain each one of those problems later in this video. All right, here we go. Let's start at the top. Problem number 1, is 2, 7 a solution? Sorry, I kind of scribbled over this. 2, 7, is it a solution to this system of equations? So here's what I'm going to do. I'm going to take this and I'm going to put a 2 where the x is, 2 times x, 2 times 2. And I'm going to put a 7 where the y is and see if that comes out to 11. Does it? That's 4 plus 7 is 11, yes. But it's also got to work here. So let's try this. What was y supposed to be? Remember, y is the second one. Y was supposed to be 7. 3 times x, what was x supposed to be? 2 plus 1. Let's see if this works. Is 7 equal to 3 times 2 plus 1? 3 times 2 is 6. 6 plus 1 is 7. It works. Okay, so that's why the answer is yes on this one. Yes, that is the right solution. But if you can't explain what you just did, then you're only going to get 1 of the 2 points on this problem. The other point is, somehow explain to me how you knew that the answer was yes. So you could say, I know that the answer is yes because I plugged x and y into both equations and both equations were true, right? Something like that. Or if the answer came out to no, you could say I plugged in x and y and one of the 2 equations or both were not true. But somehow explain to me how you knew the answer was yes or how you knew the answer was no. All right, number 2 is also going to have an explain part of it as well. But before we get to that, let's figure out what the answer is. Okay, I can see right off the bat, because I understand the graphing method, that this is going to have one solution. How do I know this is going to have one solution? Look at the 2 slopes. This one has a slope of -2. That means it's going downhill. This one has a slope of 3. That means it's going uphill. That means I'm going to have an uphill line and a downhill line. They're going to have to cross in one place, right? They're not parallel. Are they parallel? No, right? And they're not the same line. They're 2 different lines because they have 2 different slopes. So only check the box that says no solutions if the slopes are the same but only check the infinitely many solutions if the slopes are the same and the intercepts are the same. All right? So that gives you a lot of different ways that you could explain how you knew that there was one solution on this, or on the test, maybe how you explain that there's no solutions, or how there's infinitely many solutions. You could talk about the slopes and the intercepts. Different slopes mean there's one solution. Same slope means it's no solution. Same slope and same intercept means it's infinitely many solutions. All right, the other way you could do this is just try to solve the system. So if you have this, could I do substitution and then substitute, and basically I could solve this problem, and once I get a solution, I could say, I knew that there is one solution because I solved it, right? And if you did, then that's a great explanation as well, all right? So you can just try to solve it and see what happens if you want to make that your explanation for this as well. Okay, that's number 1. And number 2, 2 points on each. 2 points for number 3. 1 point for getting the graph right, 1 point for getting the solution right. So this is the only problem on the whole test where you have to know how to graph. If you understand slopes and intercepts, we should be able to graph this without too much of a problem. But remember, you are never totally out of luck. If you don't remember how to do slopes and intercepts, you can always plug numbers in, get numbers out, number juicer style, get some dots, follow the pattern, connect the dots, and graph it that way. Either way is totally fine. I'm going to do it the easy way. The easy way on this one is the intercept, the y-intercept is -2. So I'm going to start at -2, right? -2, -2. Easy, right? Where's the other line going to start, by the way? +1. So the other line is going to start here. Then you use the slope, right? Remember, the number in front of the intercept is the slope. And if this is 1/2, that means this one goes up 1/2. And then it'll go up 1/2 again. We could even count that pattern the other way. And boom, now we have a good idea of what our line looks like. And we can even connect the dots to show that's the first equation. What's the second equation going to do? We already said it starts at 1, but its slope is negative, so it's going to go downhill. Down 1/4, down 1. Oh, there's my solution, right? So there's my graph, and here's my solution. What are the coordinates of that point right there? 1, 2, 3, 4 is my x-coordinate, and 0 is my y-coordinate because it's not going up or down from there. Okay, if you weren't sure if you got this right, could you check this by plugging it back in to x and y, and plugging it again in to x and y, just like we did on number 1. Remember, checking by plugging in, and then yes, that's the right solution, or no, that's not the right solution? You could do that at the end of every system of equations problem as a way to double check your work to make sure that you got it right. And I would say, when it's a test and your score really counts, double checking is a good idea. Don't you think? I think so. Double checking is a good idea. You could even triple check some of these by doing different approaches. Okay, number 4. There's a bunch of words about Yancey and Xavier and their ages. Ultimately, it gives you the system of equations. So, right, just solve it. On this, I would use substitution. If y equals this and y equals that, then this has to equal that. Boom, substitution, right? What am I going to do to solve this? Well, I could subtract 2x from both sides. I'm going to actually subtract 4x from both sides. Doesn't matter. You'll get the same answer either way. Divide by -2, divide by -2. What's -2 divided by -2? X equals 1. So Xavier is 1 year old. Yep. And then it says Yancey is 2 times as old as Xavier. So Yancey is 2. Now go back and check your answer by rereading. Okay, we think Yancey is 2 and Xavier is 1. Yancey's age is 2 less than 4 times Xavier's. What would be 4 times Xavier's? 4, right? Is this 2 less than that? Yep. Check. She is 2 times as old as Xavier? Yep. Check. Now we know with 100% certainty that we got this problem correct. All right, very good. Number 5 is a word problem. It doesn't give you the systems of equations. You have to figure out the systems of equations yourself. Or, if you want, you can just find numbers that add up to 91 and then see if their difference is 11 and guess and check and guess and check and guess and check until you find some that work. It's a test, and so you want to get this problem right. And if you have to do it that way to get it right, right? Be a good problem solver, persevere. The better way to do it is, let's translate this into a sentence. The sum of 2 numbers is 91. Their difference is 11. Difference means subtraction. Boom. Now we have a system of equations. On this one, I'm thinking, let's add. Elimination method. 2x, y plus negative y is gone. 91 plus 11 is 102. So I'm just going to divide by 2, and I get x equals 51. Okay, if x equals 51 and the sum is 91, it's got to be 40 because that's what adds up to 91, right? So what are the 2 numbers? 51 and 40, or 40 and 51. Doesn't matter which order you put them in. Those are the 2 numbers. And just check it. They do add up to 91. Is their difference 11? Yep, this one's 11 more than that one. Yay. All right, there's the front side. Hope we're doing well so far. Let's look at the back side. One more word problem about apples and bananas and their calories. Let's read this and translate. 2 apples and 1 banana contain 285 calories. Okay. I don't think I need to explain that too much. Hopefully that makes sense, right? 2 apples and 1 banana contain a total of 285 calories. An apple has 15 less calories than a banana. Okay, so that's going to look like this. An apple has the same amount as a banana, but 15 less, right? 15 less. There we go. That's my system of equations. On this one, I don't think I would use elimination or graphing. I think this one is going to be a substitution problem. So if an apple is a banana minus 15, I'm going to put a banana minus 15 right where this A is, and then rewrite that as 2 times a banana minus 15 plus a banana equals 285. And then you just need to solve that equation. So here's what that's going to look like. 2 times b is 2b. 2 times minus 15 is minus 30. Plus you've got a b over here, and then equals 285. Right? Pause it if you need to see where I came up with that and follow along. On this, if I have 2 bananas and then another banana, that's 3 bananas, right? 2 bananas and another banana. And now it's getting closer and closer to looking like a solvable equation here. So I would try to get b by itself. So I'm going to get rid of the minus 30 with a plus 30, because that's not attached to the variable. Then I will get rid of the thing that is attached to the variable. Get rid of that 3 by dividing. If 3 bananas are 315 calories, how much is 1 banana? That's where a good old calculator might be handy. 315 divided by 3 is 105 calories for a banana. 105 calories for a banana. By the way, if you don't bring a calculator to class with you for the test, what are you doing? Bring a calculator, right? You're allowed to use a calculator. Bring a calculator. You got to bring a calculator. Don't miss that opportunity. Bring a calculator on this week when you are going to take the test. Bring it. Bring it. Don't forget it. Okay, we didn't finish. We know what an apple is, 105. And Or no, so we know what a banana is. That was a banana because that was B. What is an apple? 15 less. So what's 15 less than 105? 90, right? Just boom. And then just check it over here. Check it over here. 2 apples, how much would that be? 90 plus 90, right? And 1 banana is 285. Does that work? 90 and 90 is 180. 285, it works. We're 100% sure that we got that one right. And now we can move on to the other problems in confidence, feeling great about ourselves. Good job, us. Okay, the rest of the test is just 6 different systems of equations. It just says solve. Are you allowed to guess and check? Sure. Are you allowed to graph? Sure. Are you allowed to use elimination? Sure. Are you allowed to use substitution? Sure. You can do this however you want to. And if you like the graphing method, I even put some optional graphs there that you could use as scratch paper if you want to try the graphing method on any of these. So feel free to do the graphing method on any of those if you want to. On number 7, it's all lined up nice and pretty for elimination. So I'm going to eliminate. And when I can do add, 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 I like to do add, add, add. And this is going to work because y plus negative y is going to be gone. Opposites, right, cancel out. X plus x is 2x. 20 plus 8 is 28. Divide by 2, divide by 2. X equals 14. So I know half of my answer for number 7 is 14. That's the x part. Now I've got to figure out y. Oh, well, if x is 14 and it adds up to 20, y must be 6, right? 14 plus 6 equals 20. Boom, just logic, right? Yay, for elimination method. No problemo. Number 8, I don't think we can do elimination. It's not lined up right. So I'm going to do substitution. And if y equals 5x plus 6, then I can put 5x plus 6 right here. And just solve that. And we effectively did eliminate the y, right? So you could call this the elimination method, I guess, if you wanted to. 7x plus 6 equals 13. Take away 6, take away 6. Hey, that's 7. 7 times what makes 7? 1, right? X equals 1, right? Divide by 7. 7 divided by 7 is 1. And then, if I know that x equals 1, just put a 1 right here. What's 5 times 1? 5 plus 6, y equals 11. Again, you can always check any of these answers, right? If you want to make sure that it works, put a 1 right here, put an 11 right there, and see if it works. 2 times 1 is 2, plus 11. 2 plus 11 is 13. Check. Yep, we know. We're good. We got it. Okay, number 9. I think number 9 is a good elimination problem. And this time, I'm going to have to subtract. Because to get 2x to cancel 2x out, I'm going to have to do 2x minus itself. That means I'm going to have to subtract over here. So what's negative y minus 3y? So you've got a negative 1, and then you're taking away 3 more. That means you've got negative 4, right? Negative 1 yak, and then minus 3 yaks puts you even more in the yak hole. Negative 4 yaks. I don't know if that makes sense, but whatever. 5 minus negative 3. What happens when you do minus a negative? It becomes plus a positive, so 5 plus positive 3 is 8. And I'm just going to divide by negative 4. What's 8 divided by negative 4? Negative 2. So y equals negative 2. Be careful when you put this in your answer column. Where am I going to put the negative 2? It's y, not x. So put the negative 2 there, because it's a y that equals negative 2. And then from here, you're going to use that to help you figure out x by doing maybe something like this. Put a negative 2 here and make this 2x minus negative 2, right? Minus y, which is negative 2, equals 5, right? Did you see where I came up with that? Hopefully. If y is negative 2, I could put a negative 2 right here. Okay, then this is really 2x plus 2 equals 5. Take away 2, take away 2, 3. Uh-oh, I'm going to get some kind of a fraction-y decimal-y thing. Or I could leave it as 3 halves, or could I say x equals 1.5? Sure. And on any of these, by the way, on any of these, I could write my answer as x equals, y equals if you want to. You don't have to put it with parentheses as an ordered pair. You can write it as your two solution equations if you want to. Either way is totally fine. Okay, number 10, I think we're back to substitution here. If y equals 3x, let's put a 3x in for y. That would give me 6x minus 2 times y, but y is 3x, equals 18. So what's 2 times 3x? 6x. 6x minus 6x equals 18. Uh-oh. 6 xylophones minus 6 xylophones is nothing. What's happening here? No solution. No solution on this problem because this is a lie. 0 doesn't equal 18, right? So this system of equations has no solution. All right, just a couple more, 11 and 12. Number 11 is the one problem on this test that I think you should probably just graph it. I think the easiest and quickest method for number 11 is graphing. So if I graph the first equation, I'm going to start at 5, boom, and I'm going to go, my slope is -3, which is down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. There's my first one. What about my second equation? It's going to start at -2, and my slope for that one was 1/2. So it means I'm going to go up 1 over 2. There's my solution right here, right? There's my solution. What is the point right there? It's 2 is my x-coordinate, and -1 is my y-coordinate, so that's my solution, 2, -1. Could we do elimination on this one? I guess it's lined up, sure. Could we do substitution? Sure, I could say y equals this and y equals that, so I could say this equals that. And if you're real scared of that fraction, could I turn that 1/2 into 0.5? If you're more comfortable with that, sure. Any of this is fine. You'll still get the same answer, by the way. I'll just show you partway through this. You'd get 5 equals, what's 0.5 plus 3? 3.5, right? And then you'd add 2. You'd get 7 equals 3.5x, and then you divide by 3.5, and you'd get x equals 2. And then you could figure out the rest from there. All right, so it's good to know how to graph, right? But you can also do it by substitution if you want to as well. Last one. I've got 5y equals -10x plus 15, y equals -2x plus 3. I could do substitution, and I could put -2x plus 3 right in here for 5, right? Let's do that. Let's put a -2x plus 3 right here where that 5 is. Let's see what that would give me. 5 times -2x plus 3 is times this by 5, -10x plus 5 times 3 is 15. And then on the right side, I would have -10x plus, oh, wait a second. What's going on here? Can you see? Can you see? Can you see? When the left and the right are exactly the same, this is infinitely many solutions. This is an infinitely many solutions system. All right. I'll show you how to do that one with the elimination method as well, just for the heck of it. They are lined up, but 5y and y don't cancel, 10x and 2x don't cancel, so I'd have to multiply this whole thing by 5, right? If I did that, what would I get? 5y equals -10x plus 15. Wait a second. That's the same equation twice, right? Infinitely many solutions. Ding, 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 ding. Okay, so hopefully we get that. You can use graphing. You can use elimination. You can use substitution. You can double check your answers on this thing. You can triple check your answers on this thing. One way or another, I hope this video was helpful for you, and I hope that you are ready for the real live test, because it's coming up, okay? Bring a calculator. And be resourceful. Right? You've got different tools that you can use to solve a system of equations, right? Be resourceful and know how to use all the different tools, even if that means guessing and checking. Be resourceful. And some of these problems take a while, so persevere. You can do it. You don't have to be fast at it, right? Persevere and you can get there. That's all I got to say. Thank you for watching this review video. See ya.